Welcome everyone for the second lecture of this ISSS series, Introduction to Astronomy and Astrophysics. Today we will learn about solar system objects, the objects those are in our neighborhood, and we will cover planets, asteroids, comets, and the places where they live. So today we are starting the solar system objects, our neighborhood lecture. This is the second lecture of this series. We all know about the 8 planets of the solar system. So from the sun there is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Here the planets are with the planets, the distance from the sun to those planets and the diameter has been mentioned. You can see the Mercury has diameter of about 5000 kilometer. The Venus has a diameter of 12,000 kilometer, and so not diameter, I guess, diameter of 12,000 kilometer. Earth has diameter of also 12,000 kilometers. So Earth and Venus are about same distance, about same size. Mars, Jupiter, Saturn, Uranus, and sorry, these are not the diameter. These are the distance. I need to confirm that from Sun to the planets. Sorry, yes, the diameter sizes are given in the approximate diameter of each body. Yes, there are these are sizes. I was correct. The Mercury is the smallest among all the planets. The Mercury is 5000 kilometer because Mercury has the diameter of 5000 kilometer. Mars has the diameter of 800 kilometer, 68,000 kilometer, 66800 kilometer. The Jupiter has the diameter of 143,000 kilometer, whereas Saturn has diameter of 120,000 kilometer. Neptune and the Uranus are shorter in diameter. You can see those by their size. Now by composition we can classify planets in the 3 category. One type of planet is the rocky planet, another planet is the gas giant planets, and another is the dwarf planet. The rocky planets are the inner solar system planets. They have comparatively smaller size, but they have higher density due to rocks, and they are composed with the heavier elements. So the inner solar system planets such as Mercury, Venus, Earth, Mars, those are categorized as the rocky planets. Other type of planets are the gas giant. Those are the outer solar system planets which have very high mass, but they have the lower density and their lighter elements are abundant in them. So gas giants are the Jupiter, Saturn, Uranus, Neptune, and Pluto is no longer a planet. So but we are here in the picture, the planet, this is the very old picture, so there here the Pluto has been mentioned. If you wish to know the distance from the sun to planets, we know the Earth is at distance of 1 AU, but the Mercury and the Venus, they are less than 1 AU, we know. So Mercury is about 0.4 AU and the Venus is about 0.7 AU, and the Mars is about 1.5 AU from the sun, and the Jupiter is about 5 AU. The Saturn is about 9.5 AU. Uranus and the Neptune, those are comparatively further. Uranus is about 20 AU and the Neptune is about 30 AU. And there's another category of planets, or the last category of planets are the dwarf planet. Those are sometimes called the failed planets. They generally lie in the very outer solar system or they are present in the asteroid belt, present as asteroid belt object. And this very outer solar system planets are have very low mass. They are sometimes icy bodies. They are comparatively small in size. Such dwarf planets are the Pluto, Sedna, Eris, Makmak, Ceres. Those are some example of dwarf planets. So until now we have known that the how is the planetary size varies. How is the planetary distance from sun to the planets varies. How what is the planetary size? This is the diameter of the each body here is shown. So Mercury is the has the smallest diameter, and the Jupiter has the highest diameter. Now we should know about our seven planets, or our seven neighbors, and what is their distance, how is their size, what has the missions have been done for them. So here first comes Mercury. It is the closest planet to the sun. It is about 46 million kilometers from the sun. It is the smallest planet. It is just 1.4 times bigger than the moon. Mercury passes the shortest year, which is the 88 days. It is the fastest planet. It is orbiting with velocity of 47 kilometer per second. It has the longest day. Longest day is 59 Earth days. It has the extreme temperature because it is the closest planet to the sun. Is sometimes it is the side which is very the side of the Mercury which faces the sun has temperature of about 500 degrees Celsius, but and the other side which is the dark side of the sun which does not faces the sun, this is extreme, that has extreme cold, that about 100 minus 180 degrees Celsius or minus 200 degrees Celsius, around that. So this planet has extreme temperature variation. So any geological activity of this planet, or the formation or the composition of this planet must be affected by this kind of temperature variation. This Mercury does not show any ring, and the Mercury does not have any moon. There are different missions has been planned since 1960 to the Mercury. 1960 was the 1960 or that time. From that time, this planetary science flourished because of the Cold War over, and the Mariner series missions were Mariner series missions were the first mission to the Mercury. In 1974 to 1975, NASA did a flyby of the Mercury by Mariner 10. A series of robotic spacecraft then at that time a series of robotic spacecrafts were sent for exploring different planets such as Mars, Venus, Mercury, and those are named as the Mariner 2 to Mariner 10, and they did not landed on the planets. They did the flyby of the planet. Another very new mission to the Mercury was the Messenger mission, which was some close to our lifetime. First satellite which orbited Mercury and provided the detail about its surface atmosphere. This messenger probe studied the geology of the planet, magnetic field of the planet, and the chemical composition of the planet. As the Mercury is very closer to the sun, so it is believed that the sun's magnetic field and the field is affecting Mercury very much. So one crucial way to understand how the composition or how the structure of the Mercury is understanding the magnetic field of that planet. Another mission is the BEPI combo mission. This was a very recent mission. It was a joint mission by the ESA, that is the European Space Agency, and the JAXA, the Japanese Space Agency. It started in 2018, and it is set to arrive Mercury in 2025, this year. The JAXA has also a pilot of the with named as a Mercury magnetospheric orbiter, which also will study the magnetic field of this planet. This will be an orbiter mission, not a test down mission. Uh, then there are three notable mission to Mercury. One is the Mariner 10, another is the Messenger, and another is the Bepi Combo, which is the current or the future mission, you can say. Now it comes to the Venus. It is the second planet from Sun, and distance of this is about 108 million kilometer. It has about diameter of about 12,000 kilometer, about 0.9 about 90% of Earth. Sometimes Venus is called the Earth twin. It orbits the Sun in 43 Earth days. It has year length of 225 Earth years. It does a retrograde motion on the sky. We will learn about retrograde motion in the upcoming lecture. It rises in the west. This is one of the hottest planet. It has a surface temperature of 462 degrees Celsius. Venus does not have any rings or any moon. Also for the Venus, there were multiple missions. The Mariner 2 was did the first successfully flyby of the Venus. Another mission is the Venera program, which was about the Russian presidency, which including landers, multiple mission including landers, which transmitted data from the surface of Venus. And another mission was the Magellan mission, which mapped the surface of Venus using synthetic aperture radar. It was a NASA mission within at time of 1990. This Magellan used to measure the gravity geology of the Venus. Magellan found that the Venus surface has lava, so there must be some volcanic eruption in some recent past. So the Venus has not been Venus formation is still going on, or the Venus as the lava Venus formation is still going on, because we get the volcanic eruption signature at the Venus, and the Venus gravity they found is related with the surface topography, or the surface topography, or the height of different surface areas. Sorry for the I guess I am audible. Another mission to Venus is the Akatsuki. It was a mission by the Japan. From the name, you can understand. Currently, this mission was sent to in 2010, and this is in the present epoch. This is also present. Currently, this mission is studying the Venus's atmosphere, and it is searching the weather pattern in Venus, presence of cloud in the Venus, and any sign of the volcanic activity in its atmosphere. The future mission is those are planned for the late 2020s era. That is the Da Vinci and Veritas. This Da Vinci and the Veritas thus will be two notable future missions which are aimed for studying Venus's atmosphere and the geology. Now we have until now we have known the two planets. Those are the Mercury and the Venus. So from the this we have known that the Mercury show the extreme temperature variation about minus 180 degrees Celsius at the back side to the front side of the sun. This has the about greater than 400 degrees Celsius temperature. Mercury has do not have any ring or any moon, but a moon as well. Venus do not have any ring or moon. There were different space missions since 1960, such as the orbiter missions, which studied the geology of the planet and the atmosphere of the planet, both the two planets. And the Venus is the twin planet of Earth. It has some 12,000 kilometer diameter. So one interesting thing about Venus is the scientists are planning to study Venus and the composition of Venus, the evolution of Venus, the activity, the magnetic field of Venus, to know how the planets, just like how the Earth-like planets form, or how the Earth-like planets evolve. As these two are the similar composition, similar size. So if we can study one as a prototype, this would help for our understanding. Now it comes to Mars. The Mars is the red planet, known for its reddish appearance on the sky due to its iron oxide. Mars has the thin atmosphere, mostly carbon dioxide atmosphere with low pressure. Mars have the polar cap, which contains water, and the ice, that is carbon dioxide. Mars surface has different features, that is the canyon, volcanoes, and impact craters. Mars rover like Curiosity or the Perseverance has explored Mars. In the recent from the 2000, there is extensive search for the any past or present microbial life within the Mars. Mars is carrying on. Day and life cycle. Mars have the similar life cycle like the 24.6 hour day. Dusty storms is the occasional global dust storms can obscure the surface of the Mars. Future missions for the future crew missions will be sent to Mars by this century. It is hoped so. Mars has has two moons, such as the Deimos and Phobos. Phobos is the biggest moon, and the Deimos is the smallest among them. There were different Mars mission, or the many missions happened for the Mars. One is the Mariner mission. First mission which is the flyby of the Mars. Another mission is 1975. There were missions such as the Viking 1 and 2. These were landed mission by NASA. Mars Pathfinder mission was 1997, which included Sojourner rover. Mars exploration rovers such as Spirit and Opportunity was sent in 2003 to explore the Martian surface. Okay. Another mission was after 2003. There were Curiosity rover, which was sent in 2012, which is currently active also. It is exploring the crater of the Rustic Canyon. Here I have given the link which updates the status of the Curiosity mission from the NASA website. And the Perseverance rover was the very recent mission. It was sent in 2020. This is actively searching the signs of any past life and collecting the sample. Also late 2020 or 2020, that is around 2030 or after, the NASA and ESA both organizations had previously planned to send some sample collector, some lander sample collection, and bring back this kind of mission. These missions will be sometime within 2050. We can hope that. Also there were there are Indian missions to Mars, which we know. Those are planned. Another mission is the lander, and this planetary science. Sometimes we came across the orbiter, lander, rover. The orbiter we can understand. Orbiter just go. Orbiter can be two type. One orbiter can go to the planet. It couples to the orbit of the planet, and another orbiter can be another object, satellite can be, it will just do the flyby of the planet. It will not be caught in by the gravitational effect of the planet. And another two types is the lander and the rover. These two terms also is the very common. But they are different in the mobility, purpose, design, and the usage. Lander has the stationary thing which will go and just stop, but the rover will move across the surface when it reach to the surface of the planet. Purpose of lander so is the connecting the location from the sample from the sample, or conducting experiment in the one location. But the rover will visit multiple sites on the planet, and it will explore the planet just like a small baby. And the design of lander have the robotic arms or drill, so that it can go to it can drill the surface of the planet. But the rover has the wheel or tracks which is the movable, and the wheels and track would be so strong so that it does not get affected or broken in the surface of the planet. So before sending the any rover, scientists have to do multiple check of the planet's geology, topology, how will be the surface of planet, etc. Those consideration must be taken care. And the usage of lander is studying deep surface conditions, weather condition, and the local environment, keeping being from a constant viewpoint. But the rover would usage is very different than lander. Rover will map the terrain, search for any signs of life in different position or the different position of crater, and analyze different surface feature on the planet. So in the now it we ended the months. Now we can go to the Jupiter, the largest planet of our solar system. Jupiter is a gas giant composed of mainly hydrogen and the helium gases. Jupiter has the rapid rotation, has the shortest day among all planets, that is about 10 hours. Jupiter have the strong magnetic field. It generates powerful, it have a very strong magnetic field. Uh, Jupiter has a persistent storm that is larger than even the size of Earth, which is known as the Great Red Spot of Jupiter. Jupiter have the 79 moons. Jupiter's moon are the Io, Europa, Ganymede, Callisto. Those four Galilean moons were detected from the Galileo's time, and these moons also have different activity due to the interaction of the gravitational interaction of Jupiter, which we will do not cover. But the Io moon has some volcanic activity due to the gravitational interaction of the Jupiter. Jupiter is so big it influences the asteroid belt, that are the failed planet or the planetesimal, and even some small comet asteroids orbit this Jupiter. Jupiter does not have the solid surface; it lacks solid and the rocky surface. So this, from the Jupiter we are starting to move starting the discussion of the gas giants. So if you see the Jupiter has a great red spot, junior, the small red spot, the superstorm region, the hot spot which is the in the equatorial region, and this brown birch. These are all the features of the Jupiter atmosphere. Now we know Jupiter is the biggest planet in the solar system. It is about distance. It is after the distance of the Mars and asteroid belt. It has radius of about 70,000 kilometer. 70,000 kilometer. Uh, its day length is about 9 hour 56 minute. It has orbital period of about 12 years. Its surface temperature is about 21 degrees Celsius. That is very low than the inner planet. Core temperature is about 35,000 degrees Celsius. Jupiter has 71 9 moons. This is the not updated. There are different Io, Europa, Ganymede, Callisto. These are the different moon. Jupiter's core, or the whole Jupiter is divided into different type of layer. That is, the Jupiter's atmosphere is about is 21,000 kilometer. It contains the molecular hydrogen and helium. Jupiter has a mantle layer which contains the liquid metallic hydrogen and helium, and Jupiter has a core which is the dense hot core, which is about 20,000 kilometer in diameter. Here is the distance diameter of the each region has been shown. Jupiter's great red spot is a giant storm or cyclone that has lasted over 300 years from now. Jupiter atmosphere is made of helium and hydrogen. There is about 90% of hydrogen and 10% of helium in Jupiter atmosphere. So for this, knowing the largest planet of the solar system, the different missions were sent. This was from the 1973. The Jupiter missions are carrying out. The first Jupiter missions were Pioneer 10 and 11. The first Jupiter missions were Pioneer 10 and 11. Sorry, there was some problem. So I should share the screen. Sorry for your inconvenience. There was first mission to Jupiter was the Pioneer 10 and 11. This was the flyby mission, of course. It was by NASA. In 1979, NASA provided Voyager 1 and 2 were sent, and this Voyager 1 and 2 provided the detailed images and data about Jupiter's atmosphere, or the Jupiter's surface, and about the Jupiter's moon. Another two missions were 1995 and the Juno. This were studying was sent. Galileo was the orbited Jupiter and it studied its moon. This was one of the main missions to Jupiter. Juno is the most current mission which studying the Jupiter's atmosphere, the magnetic field of such large object, and the gravity of this object. And the JUICE mission, which was sent in 2023, it was the Jupiter Icy Moons Explorer. It was mainly for studying Jupiter's moon, particularly the moons that are Europa, Ganymede, and Callisto. And because it is believed that if we can study this moons, or the moon and this moon surface, we can get some hint about how the gravitational how the planet formed, how the moons formed, how the gravity affects in this formation. From those perspectives can be studied by studying the moon surface or the moon topology. So our first gas giant we completed. Now we will move to Saturn, the ring planet of the solar system, which has the visible ring from the telescope. Ring giant, known for the stunning ring system made of ice and rock. This is the second largest planet after the Jupiter in our solar system. This is a gas giant composed mainly of hydrogen and the helium gas. It has rapid rotation, has a short day of approximately 10.7 Earth hours. It have numerous moons, just like Jupiter. Sometimes some astronomers say that this are just Saturn have many moons larger than the Jupiter. It has 80 moons, including Titan. Saturn has lower density than Jupiter, of course. Jupiter rings of Saturn is one of the distinct feature, and one of the exciting feature also, and exciting interesting feature. And rings are composed of the ice particle and the rocky debris. Jupiter has a rings have distinct feature, and the rings are composed of ice particles and the rocky debris. It has a hexagonal storm pattern observed from the North Pole. So Pioneer 11, which was a NASA mission in the 1979, you can see the time. Is also made flyby of Saturn, just like flyby of the Jupiter. Voyager 1 and the 2 provided when crossing the Saturn, provided the detailed image and the data about Saturn and its ring. And the Cassini-Huygens is the most recent mission, which lasted for about 20 years. Cassini-Huygens, which orbited Saturn. It was an orbital kind of mission by NASA, and it studied the Saturn's atmosphere, Saturn's rings, Saturn's moons, including landing of Huygens on the including Huygens landed on the Jupiter satellite Titan. Titan is the biggest satellite or the biggest moon of the Jupiter. Saturn. Sorry. So Saturn is the Saturn is after Jupiter. It has radius of about 60,000 kilometer. It has day length about 10 hour 42 minute. It has orbital period of 29 years. That is, it orbits Sun in 29 years. It has a core temperature of about 11,000 degrees Celsius. It has about, moons are here, you cannot trust because it is a just cut out from a Google image, and it is not updated. I just used it for the good looking description. Saturn has different moon other than Titan. Titan, Rhea, Dione, Tethys, Enceladus, Mimas, those are also the Saturn's moons. Saturn's ring are consist of ice cube, that is some icy body. Saturn is the second largest planet and the lightest planet in the solar system, lighter than the Jupiter. Saturn also is divided into different parts. That is a rocky part to the atmosphere, the gaseous atmosphere. On the core, the core is made of rock. Then there is an ice layer. Then there is a metallic hydrogen layer, and there is a molecular hydrogen layer, and there is at the top there is a gaseous atmosphere of Saturn. Saturn radiates heat into the space 2 times more than it receives from the sun. So it is one of the coolest planet in the solar system. Composition of Saturn's moons are the molecular hydrogen is about 96.3%. Helium is about 3.25%. Other elements are about 0.45%. More than 40% of satellites of the solar system is found to revolve around Saturn. Both poles of Saturn have intense long-lived cyclonic storm. The North Pole has features of the hexagon you can see in this image, and this is a unique standing wave cloud pattern of Saturn. So this kind of eye of Jupiter or the hexagonal pattern of Saturn, Those are some standing wave pattern of the storm pattern. Standing wave storm pattern. If you can here see the hexagonal shape at the north pole of Saturn. Now, when we saw this gas giant Saturn, we saw different zones in the Saturn. That's the rings have different division. That are the seeding, beading, airing from surface of Saturn to the outer layer, and there are different gap, NK gap, Cassini division, etc. Another prominent features are the oval of Saturn, temperate zone of Saturn, temperate belt of Saturn, equatorial zone of Saturn. One of the interesting thing to learn is what is this zone and how these zones have been formed. So, the equatorial zone is a bright whitish band around Saturn's equator that is caused by strong convective currents and the rapid rotation of this planet. It is one of the most active atmospheric region which has the frequent storms and the jet streams. And this temperate belt and the temperate zone of the Saturn at the two interesting region. This temperate belt is a darker, a banded region located at the mid-altitude of Saturn, which often appears as an alternating bright and dark zone. This belts a result from the variations in the atmospheric pressure similar to the Jupiter's banded structure. Temperate zone is a broad latitude region of Saturn lying between the equatorial and the polar areas, marked by the less turbulent weather than the equatorial zone. It also features the large-scale wind pattern and the occasional storm activities. So this temperate zone and the temperate belt have also some wind pattern, but they are less turbulent than the equatorial zone. These are less turbulent, and this is the equatorial zone is more turbulent and more stormy region, and the equatorial zone is more bright. And the oval, this term is used to describe the storm system or the vortex-like feature in the Saturn's atmosphere. This oval is often appear as a swirling cloud formation. These ovals can be long-lasting and are sometimes linked to the atmospheric wave pattern in the Saturn. Other than this different stormy stormy atmospheric zones of Saturn's surface, there is a interesting ring system in Saturn. The ring is so big, we can divide this ring in the different region from outer to inner part. There is A, B, C, D ring. D is not shown here. We will show this later. A ring is the outmost ring of Saturn's main bright rings that is located beyond the Cassini division. It consists of the ice particle and the rock fragments contributes to the Saturn's iconic ring system. B ring is the brightest and the most massive Saturn's ring, situated between A ring and the C ring. It contains dense cluster of particles, making it one of the most visually striking component of the ring system. You can see the B ring is brighter than A ring, and the C ring is fainter than both B ring and A ring. C ring is the fainter ring. This is the inner ring of Saturn, which is located to the planet, appearing the semi-transparent due to its low particle density. It lies between B ring and the planet the closest ring, that is D ring. It has several gap and varying opacity. In the ring, sometimes there is some division of the ring which you can search in the web. Here I have just listed how what is what, or how these features are different, or what is the main interesting point about this feature. So there are some Cassini division. There are Cassini division NK gap, Huygens gap, Caleb gap, Coulomb gap, and the Maxwell gap. Different region of this ring, because this ring is not continuous. The Saturn's ring is not continuous. Often there is the gaps can be seen. Cassini division is a dark gap between Saturn's A ring and B ring, which is approximately 5,000 km wide, caused by the gravitational influence of the moon Mimas. It appears as a striking empty region when viewed from the telescope. NK gap is a narrow compared to narrow gap than Cassini. It is about 400 or 300 to 400 kilometer wide gap within Saturn's. It is within Saturn's A ring and maintained by tiny moon pan, which clears the path through the gravitational interaction. It contains faint ringlet and debris within the structure. And the Huygens gap is a division within Saturn's C ring itself, features the bright ringlet within it, named after Christian Huygens, who played a role for the complex structure of the inner ring. There is other gaps in the ring, such as Scalar gap, which is about 42 km wide gap near the outer edge of Saturn's A ring, influenced by the small moon Daphanus. The moon's movement creates a wave-like pattern on the ring edges. Other gaps are the Coulomb gap. It is a lesser known and a narrow division within Saturn's C ring or the inner ring, possibly caused due to the small moonlets or the gravitational disturbances. It is one of the many fine gaps observed in the Saturn's complex ring system. In the inner ring, there is also a Maxwell gap, that is about 270 km wide gap within C ring, that contains the dense ringlet. It is named after the Maxwell, James Clerk Maxwell, who first theorized the stability of the Saturn's ring. So for the Saturn, there are different missions we have seen, such as the Pioneer 11, that was the oldest mission. Another mission, Voyager and the 1 and the Voyager 2, which took the detailed images when it was doing flyby of the outer planets. And the Cassini-Huygens is one of the notable mission, which was an orbiter kind of mission to the Saturn and its moon Titan. Those also gave us this idea about the spring and this particular gaps of the ring. And the NASA in the mid 2030s, NASA has planned a mission named Dragonfly, which will be a robocraft lander that will explore the Saturn's moon Titan. So until now, what is happening? So until now we have explored the two gas giants, that are the Jupiter and the Saturn. For the Jupiter, we have seen the great spot of the Jupiter, a different spot of the Jupiter which are caused by the storm in the Jupiter, and we learned about the composition of Jupiter, that is the Jupiter atmosphere, mantle, core, and the missions to Jupiter. This Jupiter have the solar storm in the Jupiter cause aurora due to the interaction of the charged particle from the sun and the magnetic field of the Jupiter. Such auroras is formed. And then we came to the Saturn, and we explored about the Saturn's different region, such as the equatorial region, the one of the bright region, temperate belt, temperate zone, less brighter region, the oval shape ovals in the Saturn surface. And then we explored the different ring system of Jupiter. Ring system of Saturn. That is the sorry for my mistake. Ring system of Saturn. That is the A ring, B ring, C ring, and different gaps. Those are between the rings or within the ring itself. And we explored the how the missions such as Pioneer 11, Voyager 1 2, Cassini-Huygens are carried out, and this all missions gave us idea about Saturn. Now it's time for Uranus. Uranus is the gas giant with icy component. Uranus has unique tilt. It rotates nearly perpendicular to its orbit around the sun. Uranus is extreme cold object, one of the coldest planet in the solar system, which has temperature of about minus 250 degrees Celsius about. It has a ring system. It sometimes shows a faint ring system, faint and narrow ring system. A magnetic field axis is tilted for Uranus. Unlike most planets, Uranus rotates clockwise opposite to the other planets. Fewer moons than Jupiter and the Saturn. Uranus, whereas so we have seen that the Jupiter and the Saturn, one of the most striking feature is that they have the many moons, such as the 79 moons for Jupiter and greater than 80 moon for Saturn. But the Uranus has 27 moons. So you can think that the number of moons is something correlated with the size of the planet. This was some vague statement, but one statement to notice. Few moons than the Jupiter, so Uranus has the lesser size than is lesser in size than the other two planets before planets such as the Jupiter and Saturn. So Uranus have the lesser number of moon, about less than 30 moon, that is 27 moons. Titania and Oberon is one of the moon of the Uranus. The lowest density, it possesses the lowest density within all gas giant. Uranus rings are named after Uranian rings are named rings were discovered in the 1977. Here is the Uranus. You can see here the Titania, Oberon, Miranda, Ariel, Umbriel. These are the moons of Uranus. It has a radius of about 25,000 km. It has day length of about 17 hour 14 minute. It takes one orbit around sun in about 84 years. Its surface temperature is about minus 250 degrees Celsius. Sun on the Uranus rises in the west and sets in the east. Its atmosphere to the internal core has been divided into different parts. It has an outer atmosphere. Its surface or the whole planet has been divided in different parts, just like the other gas giants. It has a core in the internal. After the core, there is a mantle region. Then there is a atmosphere region which is 8,000 kilometer wide, and other outer atmosphere or the upper cloud layer is there is a small upper cloud layer. Atmosphere of Uranus has different composed of methane, one of the main feature of the Uranus. It has hydrogen of about 83%, helium of about 15%, and the methane that is about 2%. Mission is the Voyager 2 is the only spacecraft that has been flown by the Uranus, and this mission itself provided us the data about the planet and its moon. Uranus is the coldest planet of the solar system. It is colder than the Saturn. Now it comes for the Neptune. Neptune has about radius of 25,000. It has also radius about 25,000 kilometer, approx same size than in Uranus. It has surface. It has day length of about 16 hour 6 minute. It orbits the sun in 165 years. It has total 14 known moons. His moon are Triton, Nereid, Night, uh, and others. Here you can see the names of different moons, of Neptune. Neptune has rings, but those are very dark, and their structure is unknown. The planet never is able to seen by the is this planet is never able to be seen by in the naked eye. And for seeing this planet, you need telescope. Outer this planet has been divided in different sections such as the core, mantle, atmosphere, and the outer atmosphere layers. And this planet has also similar composition with the Uranus, such as its atmosphere has the hydrogen, helium, and the methane. Hydrogen is about 80%. Hydrogen is the in the Neptune. Helium is about 19% and methane is about 15%. Neptune shows a great dark spot. Those are the anticyclonic storm spots. And the Neptune has the strongest winds in the solar system. Neptune is composed of the water, ammonia, and the methane ices with rocky core. Great dark spot, a large transient storm system is seen in its atmosphere. Features one of the fastest planetary wind in the solar system. So the Neptune has the planetary winds. Experiences a dynamic from that we can say that this Neptune has a dynamic weather pattern and the frequent storms. Neptune also possesses powerful magnetic field with the tilted axis. Neptune has the 14 moon, and among them Triton is the largest moon and the only moon with retrograde orbit. And extreme cold temperature around minus to 50 degrees Celsius. Visited only for Neptune also, the Voyager 2 is the only mission. And so in the potentially in this century there will be Uranus and Neptune. We can hope there will be more missions in the Uranus and Neptune that will do something flyby of this planet. But all thing is hope. So now we completed all our 7 nebulae. Now we will see the other objects in the solar system or the other regions of the solar system more specifically, such as the asteroid belt objects, trans-Neptunian objects, the Kuiper belt object, comets in the solar system, the Oort cloud in our solar system, and how a solar system got formed. So now, the asteroid belt is a region of space which is located between the orbit of Mars and Jupiter and contains the millions of rocky bodies. These rocky bodies are known as the asteroid. It is thought to be the remnant from the early solar system formation, and these rocky objects or the planetesimal never collapsed to form a planet due to the Jupiter's high influence of gravity, and or there can be another model. There is another model that some giant planet was formed in the past, but it broke apart and created such kind of asteroids. This thing happened in very long ago. This built when the formation of solar system was going on. This belt spans approximately 1.5 AU to 3.3 AU, that is in the astronomical unit, and majority of asteroids are within the outside portion, that is 2.1 to 3.3 AU. Here is the schematic diagram of the asteroid belt has been given. So you can see these are within the Mercury and the Jupiter. Mercury and Jupiter's orbit. There is a main asteroid belt. There is in this asteroid belt we can divide into two regions. One is the main asteroid belt, another is the Trojan asteroid belt. Main asteroid belt is the region between Mars and Jupiter, as we said. It contains millions of rocky and the metallic asteroids. These asteroids are thought to be remnants of the early planet formation, prevented from forming planet due to Jupiter's gravitational interaction. On the other hand, this Trojan asteroid belts, there are two Trojan asteroid belts. These are consist of asteroids of the planetesimal. This is located on the Lagrange point of the Sun, Jupiter, and the Tharmas, three body gravitational system, and this asteroid belts are 60 degree ahead and behind of the orbit of Jupiter. At the spatial points, that are the Lagrange point 4 and the 5, the object remains stationary. The object remains stationary due to gravitational interaction solution. Thus, the Trojan asteroids remain trapped by Jupiter's massive pull. While the main belt contains mix of composition types, different type of composition of asteroid type. Based on composition of asteroid, are categorized in three category. One is the C type, S type, and the M type. But this C type, M type, and the S type asteroids are mainly found in the main asteroid belt. At the Trojan asteroid belt are mostly C type asteroid. I have to do a small checking. I have to just add here. Stationary. Sorry for the typo. So asteroids are categorized divided into three categories based on the composition. One is the C-type asteroid, S-type asteroid, M-type asteroids. C-type asteroids are the most common type asteroid. About 75% of asteroids are the C-type asteroid. They are composed mainly of the carbon-rich materials such as materials, and also silicates. Ice are also within this C-type asteroid, and mainly these are found in the outer asteroid belt and also the Trojan asteroid belt. The S-type asteroids are composed of the silicate rocks and some metal, but the silicate is the higher proportion. These asteroids are brighter and dominant in the inner belt. About 17% of asteroid, the inner asteroid belt or the main asteroid belt, are S-type asteroid. M-type asteroid are the metallic asteroid. Metals means nickel or iron. These asteroids are thought to be remnants of the planetary core and mostly found in the middle of main asteroid belt. C-type asteroids are the most darker and primitive, while the S-type and the M-type asteroids are brighter and more evolved due to heating and the collision. Ceres and Eros and Psyche are the three asteroids. Among them, Ceres is the C-type asteroid, Eros is the S-type asteroid, and Psyche is the M-type asteroid. Psyche was a Psyche mission to study the metallic asteroid. NASA had a mission to Psyche. So both belts are key to understand. The main asteroid belt and the Trojan asteroid belt are key to understand the solar system, but there is a difference in location, composition, and the orbital behavior. The asteroid belt probably contains millions of asteroids. The asteroids in the asteroid belt come from variety of sizes, from very small size to less than a mile across, while the others are the quite large. Here in this image, 42 largest asteroids is shown. Here there is a Ceres, which is about a diameter of 1000 km. There is Vesta, Pallas, Hygiea, uh, Europa, etc. Davida, etc. Other asteroids has been shown. There's Juno asteroid, Psyche, Doris, Fortuna, Themis, Iris. Those paths has been shown. The largest object in the asteroid belt is Ceres, which is classified as dwarf planet or the failed planet, and Ceres accounts about 40% of the belt's total mass. Ceres is 1/4 of the size of Moon or the 1/4 of our Moon. It is sometimes called the dwarf planet. Other than main asteroid belt object between Jupiter and the main asteroid belt object, the Trojan asteroid belt object within Jupiter and Mars. There was some key mistake. Jupiter and Mars. There are Apollo asteroid belt or the Apollo asteroids, which are a group of near Earth asteroids with orbits that are close to group of near Earth asteroids which are close to Earth, and this orbit of those asteroids crosses the Earth path. There is, you can, in this image we have shown this Apollo asteroid belt and the orbit of the Earth around Sun. You can see this asteroid belt or the path of this asteroid crosses the Earth's path. So this is Earth's path. Amor asteroids are the class of near-Earth asteroid that have orbits approaching us but does not cross the Earth's orbit. So orbit of some asteroids in the asteroid belts crosses the Earth path. Those are called the Apollo asteroids, and the asteroids which does not crosses the Earth's path is called the Amor asteroids. So now this completes our discussion with the asteroid belt objects. Now we will go to the trans-Neptunian object. Those are the celestial bodies located in the outer part of the solar system, of course beyond the orbit of Neptune, from that, as the name suggests. There was Hydra, Ares, Pluto, Nix, Charon, Dysnomia, MK2, Mechmech, Orcus, etc. objects are there. They include the diverse range of objects you can see here, such as dwarf planet, asteroids and comets, and they are key for understanding the formation, mass content and the evolution of the solar system. All those are have less than 100 to less than 100 kilometer diameter, or the within less than 1000 kilometer or meter diameter. Another object other than the trans-Neptunian, of course, and the one thing to keep in mind, the trans-Neptunian objects can be dwarf planet, asteroid or comets. And the other objects, other belt in the solar system or the other location of solar system are the Kuiper belt. The Kuiper belt is a donut-shaped region with objects surrounding the solar system. This belt stretches out to the farthest reaches of our solar system. This Kuiper belt is stretched at from the after Neptune. So you can see it is a donut shaped region. Of this is a donut shaped region. This picture does not give you the full idea, but this will be a donut kind of thing. Uh, this Kuiper belt is divided into two distinct parts. One is the inner Kuiper belt, another is the outer Kuiper belt. I guess I'm audible. The inner Kuiper belt is more densely populated, similar to the asteroid belt between the Mars and Jupiter, but it is much larger than the asteroid belt. So this asteroid belt was this was 1.5 to 3.3, about 1.8 kilometer AU, and this Kuiper belt is greater than, greater than 3 AU, of course greater than 3 to 5, greater than 3 or 5 AU. This is the densely inner Kuiper belt is much larger. Inner Kuiper belt is the home to Pluto, and the outer Kuiper belt is a region that is scattered disk which goes out to the edge of our solar system. Here the orbit of the objects are erratic in the chaos, and the orbit of this object is still evolving. There is just a lot of bad stuff out there, and we don't know about them because we don't have a ton of data on this region. So the Kuiper belt is not only wide out into outer space, but it is also tall, hence the description of it being kind of like a donut surrounding our solar system. So one of the main questions which comes in our mind, where did this Kuiper belt objects come from? Scientists have different theory for formation of Kuiper belt. Some think that this region of icy bodies may have been the leftover from the solar system formation. The Kuiper belt is generally considered the oldest surviving piece of the solar nebula that originally formed the planet. If the ice giant Neptune had not existed, this piece might have come together and formed very similar to Jupiter-like massive planet. But because of the Neptune's gravity is so dominant, many objects like Pluto, cross-Neptunian object, those cross-Neptunian object or the trans-Neptunian objects, does not able to overcome the gravity of Neptune and unite to form a planet. In another prevailing theory is the origin of Kuiper belt. It is said that after the solar system formation, the large gas and gas giants were much closer to Sun than as they are now. But actually they migrated. The Jupiter and the Saturn's gravity pushed them outer from where they formed, which forced Uranus and Neptune into icy far reaches of our solar system. This migrating process flung a lot of material that would have been in the Kuiper belt out to the solar system entirely and formed such belt kind of region. Total mass of the scientists think the comprises Kuiper belt would be only make up about 10% of Earth mass. Some believe that there might be more stuff in the past which broke apart and scattered either inside or outside the Kuiper belt, but we do not exactly have the answer how this Kuiper belt was formed. There are different theories for the formation of Kuiper belt. Now, after the Kuiper belt, we will study what are comets and what we call comets. Kuiper belt objects can become comets when their orbits are disturbed by the gravitational interaction. Often this kind of thing happens with the Neptune's gravitational interaction. This disturbance pushes those bodies into the inner solar system, where the sun's heat causes their icy surface to sublimate and form a glowing coma and tull. So yesterday we also looked at the uh, comet close up with close up look. So comet Halley has different kind of zones. One is the nucleus, another is the dust tail, another is the gas iron tail. Iron tail is the direction of the solar wind. Iron tail tells the direction of the solar wind. The nucleus and the dust tail. And in the planet, in the comet, there is a nucleus, tail, two tail. One is the dust tail and the iron tail, and the coma. Nucleus is the dark, dirty snowball composed of ice, dirt, rock, and gas. Coma is a halo of gas and ice rock bursting forth from the nucleus. And the tail may include both duster and the iron tail. As the ions as the charged particle, it moves in the direction of the solar wind. Short period comet like the comet, short period comet like the Halley comet originate in the Kuiper belt region and follow the elliptical orbit around Sun. They lose material in the each pass and they might eventually break apart and become inactive. So study of these objects help scientists to uh, understand the transition between the Kuiper belt object and the active comets. Other than Kuiper belt, which is at the distance from 30 to 50 astronomical unit, there is in the outside of the solar system, that is about 2000 to 200 2000 to 2000 to 200,000 AU. There is another region which contains small bodies, which is the Oort cloud. Do not which region is known as the Oort cloud. Don't confuse the two region. They do have similarities, but they are indeed source of comets. But Kuiper belt is the source of mainly short period comets. Those comes within the 200 years. But the Oort cloud is the source of the comets. Sorry. Those is greater than those comes greater than 200 years. Now, what is the Oort cloud? Oort cloud sits at the outer edge of the solar system beyond the Kuiper belt. Here you can see the inner Oort cloud is about 100 1000 astronomical unit, 1000 astronomical unit to 10 to the power 5 astronomical unit. Oort cloud does not conform to the plane of our solar system, which means it's not a part of solar system stellar orbital disks where the planets orbit the sun, but instead it is thought to be a giant sphere that surround the entire thing. Here clearly this picture says the thing. So Oort cloud is not in the disks thing. It is greater than, it has the height greater than the other than the disks dimension, other than vertical dimension of the disks. The Oort cloud is distributed. You can see the inner edge of the Oort cloud is anywhere within the 2000 AU to 5000 AU, while the outer edge we do not know where is the outer edge. It could be as far out to 100,000 AU or 1.5 light year from the sun, but we don't know the exact ending point. We have to keep in mind that the closest to us, the Proxima Centauri is about the closest star is about 4.3 5 light year away. The main theory surrounding the origin of the Oort cloud is it's what is left over after the planets formed. These chunks were distributed throughout the solar system as the planetesimal, but the gravity of planets, mostly the high mass planets, that's the Jupiter, Saturn, those flung those planetesimal and flung the planetesimal to far reaches of the solar system and beyond. The gravity of the Milky Way itself is what likely to hold them outside the solar system. So it is due to the gravity of solar system, this broke apart broke apart planetesimals are hold it in a shell kind of structure around the solar system. So we have to remember a couple of interesting facts about the solar system. Unlike Kuiper belt, it is not considered to be a part of our solar system. It is a region that surrounds the solar system and interstellar space. Voyager 1 spacecraft, which has entered the Kuiper belt in last few years, would not enter the Oort cloud in another 30 years or so. Additionally, it is the distribution of Oort cloud is totally theoretical. We have never directly observed the Oort cloud or any object within it. They are just too small to be observed by telescope. A big difference between Oort cloud and the Kuiper belt is the size of bodies within them. I should rejoin. Sorry for the inconvenience. The Oort cloud distribution of Oort cloud is totally theoretical. We have never directly observed the Oort cloud or any objects within it. They are just too small to be observed. A big difference between Oort cloud and the Kuiper belt is the size of bodies within them. Oort cloud is a sphere of comets which are smaller than Kuiper belt objects. But if the Kuiper belt can be this Oort cloud has been divided into the two parts. The inner this is theoretically inner Oort cloud and the outer Oort cloud. Inner Oort cloud or Hills cloud is something disc shaped. You can see this is in the disc shape, but this has a height in the dimension in the vertical dimension. Thus lies closer to the rest of the solar system. This Oort cloud starts at the distance of approximately 2000 to 5000 astronomical unit from Sun and extend up to 10,000 to 20,000 astronomical unit. These objects in this region get influenced by the gravity of gas giants. The outer Oort cloud is the largest spherical component and extends from the outer edge of inner Oort cloud to at least 50,000 to 100,000 astronomical unit. The comets from this region approach the sun from any direction, which is why scientists believe that the outer edge is spherical. The objects in the outer cloud are loosely bound to sun and their orbits fit the gravity of nearby stars and the Milky Way galaxy itself. So the objects in the outer Oort cloud are prone to feel the gravity of the nearby stars and the gravity of the Milky Way potential well itself. The cloud likely consists of many icy planetesimal. The Oort cloud, both the Oort cloud region, that is the inner Oort cloud and the outer Oort cloud, consist of mostly icy planetesimal. This is a small object about 100 kilometer or so, made from the dust and ice, which are the remnants from the formation of the planet of the solar system. These planetesimals are so far from the sun that they react to the perturbation from the nearby stars and the gas clouds. So until now we have seen about the asteroids and comets. So one main question is, what is the basic difference between the asteroids and comets? Asteroids and the comets are different in the composition, location, surface appearance, orbital characteristics, tail formation, and the frequency and visibility. Asteroids are mainly made of rock and metal, and these are mostly found in the orbit between Mars and Jupiter. Asteroids are the solid bodies, uh, rocky bodies, and the cratered body with no visible atmosphere. Whereas comets are the composed of ice, dust, and rocky material, often known as the dirty snowballs. Location of the comets are mostly originate. They are mostly Kuiper belt objects. Sometimes they are Oort cloud object, or the farthest part of the solar system they comes. Comets have the frozen nucleus that develops a coma or the glowing atmosphere until when it reaches towards the sun. Comets have the highly elliptical orbit, often taking them far from the sun and the closest to the sun, with the sun at its focus of that orbit. And the asteroids have more circular and the stable orbit around the sun. Uh, and the tail formation for the comets has been seen. They develop the brighter tail of the gas tail and the dust tail due to the solar radiation and solar wind. Asteroids do not show such tail. Comets can be highly visible when they pass near the sun due to their bright tails, and the asteroids remain relatively unchanged and they are mostly visible through the telescope. So comets and the asteroids both are two different kind of objects in the solar system, and we just gave a difference, a short tour of difference between two objects. So now, until now we have seen different kind of object. So now we will make a difference between asteroids, comet, meteoroids, uh, and see what is their characteristic. Asteroids, comets, and the meteors that sometimes come from them are the all are leftover from the formation of the solar system. Those are formed in which formed in 4.6 billion years billion years ago. Meteoroid is the much smaller rocks or particles in those orbit around the sun. Meteor is the if such meteoroid enters in the Earth atmosphere and vaporizes, it becomes a meteor which are often called a shooting star. Meteorite: if the small asteroid or the larger meteorite survives, its fiery passes through the Earth's atmosphere. It will land on Earth's surface and then it is called the meteorite. Asteroid, you have seen that these are the rocky fragment which are left over from the beginning of the formation of solar system. And comets are the cosmic snowballs which has the nucleus, develop coma in our atmosphere. These are the cosmic snowball of gas and dust. Those make the sweeping orbit around the sun, and the comets have the orbit of the some more elliptical orbit, but the asteroid have some stable and the circular orbit. And the meteor is the very much smaller than the asteroid, or the very small rocks than the asteroid, which can enter in the Earth atmosphere and create the meteor shower or meteorite when it falls on the atmosphere Earth's surface. And the asteroid are the bigger version of the meteorite rocks. Now, the main question in the planetary science is how did our solar system came to be? Now, all this began at the 4.6 billion years ago when a gas cloud which contained gas and dust, mostly the hydrogen gas and the other dust hydrogen gas, helium gas, and other dust particle was there. And this at some point, this gas cloud collapsed itself, started to collapse itself. Such collapse can be due to there was an old star. There was a star, not very old. There was a star which got dead and gave rise to the shock wave or the supernova explosion was there and compressed the gas cloud. So this gas cloud compression, this shock wave created the different parts created a mm, this shock wave uh, gave the energy to collapse, and as a result collapse, this cloud was fragmented in the small part from the bigger this the big cloud fragmented in the small part, and this nuclear fusion, this cloud created a flat spinning disk of dust and gas. And the nuclear fusion occurred when the hydrogen atom fused to form the helium. And when this material was collected in the disk, and this created a disk kind of shape. And when enough material was collected at this disk center, the nuclear fusion began. Our sun was born, and it gobbled up to 99.8% of all the material from the cloud. So the material left behind by the sun clumped together into bigger and the bigger pieces. These clumps became planets, dwarf planets, asteroids, comets, and moons. And only rocky things that would survive close to sun, so gaseous and icy material collected further away. That's how the solar system came to place today. Comets and asteroids are the leftover remnants of the sun system formation. So I was in this timeline. I was something not very clear. I should tell this once again. So around 4.6 billion years ago, there was a cloud of gas and dust. So this gas and dust got influenced by some supernova explosion. A shock wave created due to a supernova explosion heated this gas cloud, and this gas cloud began to collapse. As the gas cloud began to collapse, the big cloud got fragmented. There was a much smaller piece of cloud formed from the bigger cloud. Now, one such bigger, smaller cloud created a flat spinning disk of dust and gas particle, and this until this epoch. In the disks, there was some nuclear fusion started to occur, when the hydrogen atoms fuse and form the helium gas. When there was enough material collected in this disks center, and the nuclear fusion began, our sun was born, and it took about 99% of the material. The material left behind after the formation of sun uh, created the planets, dwarf planets, and the asteroids and the moons. Only the rocky thing could survive near to the sun. So the icy material or the gaseous material moved to the outer portion of the solar system or the system. That is how the solar system came to place today. So comets and asteroids are the leftover or the remnants of the solar system formation. Now, here is the one short chart for the planetesimal to the formation of solar system. Everywhere in the solar nebula, the tiny piece of matter started condensating from the gas. So everywhere in the solar nebula, tiny pieces of matter started condensating from the gas. At the different places of the solar nebula, there was a little bits of grit where the different compounds condensed. These small pieces of matter stuck together stuck to others, making the largest size blocks of planetesimal. Eventually, this planetesimal is collected into objects of in the size of planet. Gravity got into act when planetesimals got big. So from the planetesimal, the solar system got formed. At the beginning, there was a gas cloud. It got shocked due to a supernova and fragmented. And in some, as a result, a flat spinning disk of gas and dust formed. In this flat spinning disk, the fusion reaction occurred, and The sun was born in the disk when center of the disk uh, clumped about 99% of material, or the high amount of material, and the other materials which does not got clumped, and created the planets. So planets, dwarf planet, asteroids, comets, and moon. So in the solar system formation, different processes act. One is the large cloud fragmentation, the shock wave, due to the shock wave, which was the precursor of solar system formation. The fragmentation of the cloud and the fragmentation of cloud and the formation of disc-like shape. In the disc-like shape, the collection of matter and the formation of star, the starting of the nuclear fusion, and there was the leftover and the formation of planets. So while in this lecture, while I am telling this, maybe I am not very clear about all the steps here. I do not know, I just telling that I do not know all the steps very well. But this was a very short outline of the solar system. We will try to learn about the formation of the solar system bit more detail, or the fragmentation of the processes, this processes the big more detail in the upcoming lecture. This is one of the just a upper level view from the just from the plot. You can check this plot once again by yourself. So now there was the idea of so the main idea was the planetesimal was the main thing which formed the solar system. Everywhere in the solar nebula there was planetesimal which condensed and formed the planets. The planetesimal are the leftover after the formation of sun. And today, up to now, we have seen about the planets. We have studied about all the planets, our neighbors, and then we have studied the Kuiper belt, asteroid belt, the composition of asteroid belt object, or the division of asteroid belt object, the trans-Neptunian object, the Kuiper belt, the comets, Oort cloud, and the difference between the meteoroid, asteroid, comets, and a just broad sense overview of the how solar system got formed. Maybe I was not very clear about this thing, but I am sorry. So this ends our today's meeting. Next meeting will be on Tuesday. Thank you for your joining. Thank you.